Hey class, in this recording we're going to focus on the large intestine. As we look at the large intestine, it is by volume the largest part of our intestinal tract. It's going to receive approximately 500 milliliters or half a liter of residue a day, undigested residue. And this undigested residue is eventually going to be compacted down into approximately 150 milliliters of feces by absorbing most of the waters and salts from it. And at the very end of the large intestine, we eliminate those feces via a process known as defecation. So as we look at the large intestine, just to give you a nice overview, it starts here with the cecum, and we're then going to extend upward with the ascending colon, and then we have the hepatic flexure, sometimes referred to as the right colic flexure. We go across to with the transverse colon to the left colic flexure, sometimes referred to as the splenic flexure. We'll head inferiorly through the descending colon. We'll go across and squiggle with the sigmoid colon. Then we'll go to the rectum, where we concentrate the feces, and then expel the feces out of the anus at the end. So, as we look at our large intestine, it's about 1.5 meters, 5 feet long. And it starts at that cecum right here. And as we look at the large intestine, there's the much maligned appendix, which is going to extend inferiorly from the cecum. It's about the size of our pinky, and it has a very dense concentration of lymphocytes. The appendix used to commonly be cited as an example of a vestigial organ, an organ without a purpose. And that is not a correct definition of the appendix. A better definition, or I think a better way to describe vestigial organs, is an organ whose purpose has not yet been discovered. And when we look at the appendix, our appendix has a purpose. It is filled with secondary lymphatic tissue. It aids our immune response. We have that ascending colon, as I mentioned on the previous slide, to the transverse, to the descending colon, to the sigmoid, followed by the rectum. And then at the very end, after that rectum, we'll have the anus. Now, as we look at the large intestine, there are some longitudinal fibers that are highly concentrated. We can see that fiber right here on this slide. I'm tracing that fiber. And that fiber is referred to as the tennae coli. We also have haustra. A haustra is a pouch on the large intestine. And these pouches are caused by variations within muscle tone. We have the circular muscle and the longitudinal muscle of the muscularis externa. And then we're also going to have an internal and external anal sphincter. The internal anal sphincter is made up of smooth muscle of the muscularis externa, and then the external anal sphincter will be anchored to muscles of the pelvic diaphragm. And as we look at these little chunks of fat that just seem to hang off of the large intestine, these little bits of fat and adipose tissue that hang off are referred to as epiploic appendages, sometimes referred to as omental appendages. And they adhere to the colon. Their function is, as of right now, unknown. So according to my revised definition of vestigial, I think these are still vestigial. We haven't figured out what they do yet, but they gotta do something because they're there. And we'll see. As we move on, the end of the small intestine, the rectum, is going to be a pocket that receives the feces, and it has 3 curves and 3 infoldings. These infoldings are called transrectal folds or rectal valves, one of which is pictured right there. And they help to keep feces moving one direction through the rectum. The rectum is designed very specifically with these rectal valves to have feces go out and not to have foreign objects go in. When foreign objects are inserted, they may tear that flap of skin which makes the rectal valve, which is not a good thing to do, because once you tear that flap of skin and expose the blood supply to the feces and all the bacteria within the feces, that individuals have increased risk of contracting diseases from the many different microorganisms that are present within their feces. As we look at the anal canal, it's about the last 3 centimeters of the large intestine. And those last 3 centimeters are located right down here. And we're going to have some anal columns and anal sinuses. Those anal columns are going to be the ridges. The anal sinuses are the indentation. They're kind of like gyri and sulci. And those anal columns and anal sinuses have lots of mucus that are excreted to help lubricate the passage of feces through the anal canal. There are also some very large veins present within the anus. These veins that are superficial, that are close, that are within the submucosal layer, can have a valve go bad in them, and if a valve goes bad, they swell up and become hemorrhoidal veins. And these hemorrhoidal veins are very sensitive, very tender, and prone to having a lot of pain when they're pressed against. And a distended hemorrhoidal vein is referred to commonly as the hemorrhoid. And things that can increase the risk of hemorrhoids include being obese or being pregnant, having lots of extra weight within the abdominal pelvic cavity, which is going to increase the pressure, the blood pressure lower down in the body. As we look at the mucosa of the large intestine, we have that simple columnar epithelium, but the mucosa of the large intestine has will typically end at the anal canal. And once we get to that anal canal, we have a non-keratinized stratified squamous epithelium. And that non-keratinized stratified squamous epithelium helps us to resist abrasional forces from that compacted residual waste, that feces, as the feces have become compacted. Occasionally, when the feces are overcompacted or too compacted, we can have constipation occur. And sometimes we end up sloughing off too much of that stratified squamous epithelium when we're constipated. It's a very painful process. It's also worth emphasizing that within the large intestine, we don't have circular folds and we don't have any villi. We don't need to maximize surface area in order to maximize the rate of absorption. We also have some blind pockets referred to as intestinal crypts. These are pockets with lots of glandular secretions sunk deep down into the connective tissue of the large intestine, the laminopropecia, and they have a high concentration of mucus-secreting goblet cells and lymphatic cells. And as we look at those lymphatic cells within the lymphatic tissue, they help protect us from the incredibly large population of bacteria within our colon. Oops, let me go back a slide here. So here's our last slide here. As we look at the histology of the anus versus the rectum, right here, right there, is the recto-anal junction, where we transition from rectum to anus. So when we look at the histology of our anus, the epithelial tissue of the anus is that non-keratinized stratified squamous epithelium with many layers of cells that we can slough off. The anal canal is designed to resist frictional or abrasional forces. Not a ton, but enough. If you're too aggressive while doing your paperwork, when you're sitting on the top of the toilet, you might slough off too many layers of the non-keratinized stratified squamous epithelium, but they regenerate fairly quickly. However, when we look at the rectum, so here, let's zoom in on that portion. As we look at the rectum, we have the simple columnar epithelium with lots of goblet cells and those intestinal crypts, those deep pockets of tissue lined with goblet cells. And since we have a simple cuboidal epithelium lining the rectum, this simple cuboidal epithelium doesn't have layers of cells to sacrifice to abrasion. The rectum is not designed to withstand frictional or abrasion forces to any high degree. I have a good friend of mine, former student, his name's Dave. He went in for just a standard colonoscopy, you know, that wonderful thing you do when you turn 50 years old. And the clinician who was giving him his colonoscopy was a little too aggressive and ended up tearing through the mucosal membrane of the rectum, and Dave had to spend 6 weeks in the hospital recovering from a sepsis infection. He had so much fecal matter enter his bloodstream that he had to be put on intravenous antibiotics and was in critical condition for a while. So try not to have those abrasional forces affect our rectum. It's not good. That's all we have for this recording. If you have any questions or comments, please feel free to post them in the class discussion board or shoot me an email. And as always, happy studies.